Today, in this video, we are going to learn the common mistakes that students commit in maths. Identify these mistakes and correct them. So the first topic that we are going to touch upon is adding and subtracting fractions. For example, what if you are given the sum 7 upon 4 plus 3 upon 11? You know, most of the students, they simply do this. They add the denominators 4 plus 11, which is 15, and then they add the numerators, which is 7 plus 3, which is 10. But this is wrong. Whenever we add or subtract fractions, we should always go for the rule which we call the butterfly rule, which means if we have a fraction like a upon b plus or minus c upon d, means either there will be a plus in between or a minus in between. So first multiply the a with d, then write plus or minus, then multiply b with c, and this will form the numerator, and for the denominator part multiply b and d. So your answer or the next step will look like this: a multiplied by d plus, or if there is a minus, c multiplied by b or b multiplied by c, the whole upon b plus d, which is this multiplied by this, the denominators. So let us do the sum again, but in a correct way. So 7 upon 4 plus 3 upon 11. So using this particular formula, which looks like a butterfly, first we are going to multiply 7 and 11, then we are going to write a plus, then we are going to multiply 3 and 4, the whole upon 4 multiplied by 11. Something like this. Now 7 11s is 77, 3 4s is 12, 4 11s is 44. So we are going to simplify this, then add the 77 and 12, we get 89 upon 44. Then try to reduce this to the lowest terms. If it is possible, do it, otherwise you have your final answer. Let us do another example. What is 5 upon 6 minus 1 upon 2? So we're going to do the same thing. 5 multiplied by 2 minus 6 multiplied by 1, the whole upon 6 multiplied by 2. So we have 10 minus 6, the whole upon 12, which is 4 upon 12, and then we can reduce this to 1 upon 3. 4 ones are 4, 4 threes are 12. So the answer to this is 1 over 3. The next topic in which the students commit a lot of mistakes is multiplying or dividing fractions. Let's take this example. What is 4 upon 7 multiplied by 21 upon 8? So 4 and 21 are multiplied, 7 and 8 are multiplied, 84 upon 56, which is 3 upon 2, which is actually correct. Now many students, they feel that we need to do that butterfly method even for multiplications, but that is not true. For multiplication, you can simply multiply the numerators, simply multiply the denominators, reduce them to the lowest terms, and you are done. Or you can do this also. You can cancel the 4 ones and 4 twos, 7 ones and 7 threes, and you have the answer directly. So remember, while multiplying or dividing fractions, please don't do the cross multiplication or the butterfly method. And what about the dividing part? So if we have 15 upon 8 divided by 3 upon 2, first of all, we need to convert this division into multiplication. And in order to do that, we need to take the reciprocal or the multiplicative inverse of the fraction which is just next to or behind the division sign. So the 2 goes above and the 3 comes down, while the 15 upon 8 remains as it is. And now you can do the cancellation and you get the final answer as 5 upon 4. So remember, when there is a division, take the reciprocal of the fraction which is after the division sign and not before the division sign. Now adding or subtracting decimal fractions. I've seen many 10th graders also commit a very grave mistake while adding or subtracting numbers which has a decimal point in it. Let's take the example 101 minus 89.37. You know what do? They take the 89.37 first, and then they write the 101 afterwards underneath, and then they subtract like 7 minus 1 is 6, and 3 minus 0 is 3, 9 minus 1 is 8, 8 minus nothing is 8, and then they put the decimal point and they get 88.36. But this is absolutely wrong, because 89.37 makes 89 a 2-digit number, while 101 is a 3-digit number. And a 3-digit number minus a 2-digit number will always give a positive answer, no doubt. So we need to follow some rules. Rule number 1: if there isn't any decimal point, put it after the last digit. Means put the decimal point after the last digit. So 101 does not have any decimal point, so we can put a decimal point after the 1 in the units place. Align the decimal point one under the other, means put the decimal point under the decimal point. Ensure that there are equal number of digits after the decimal point. For example, to solve the same sum, we write 101 point, and then we write 89.37. We write the decimal point under the decimal point, and then we write the extra zeros, because these are 2 digits after the decimal point, so we put 2 zeros. And then we do it a normal subtraction, and we get 11.36. Let's take another example. What is 10.521 plus 1.6? So we need to write this as 10.521 plus 1.6. We put the decimal point under the decimal point, and then we put the extra number of zeros as required. Then add it, and we get the right answer. Dividing certain numbers. Now look at this example and try to find what is wrong with this particular thing. 216 is being factorized over here. So the student starts with a 2, 2 ones are 2, 2 eights are 16, then 2, 2 nines are 18, 3, 3 threes are 9, 3, 3 ones are 3, and this is wrong. Now you may be asking, what's wrong with this? The wrong part over here is this, because 18 twos is 36 and not 216. So the student has committed a grave mistake over here. So whenever 216 has to be divided by 2, we start with 2 ones are 2, but then we have a 1. The 1 comes down, and 2 zeros are 0, and that 1 carries over, and it becomes a 16. And then we write 2 eights are 16, because now 108 multiplied by 2 is actually 216. Then we can proceed this normally. 2 fives are 10, 2 fours are 8, then 2, 2 twos are 4, 2 sevens are 14, then 3, 3 nines are 27, 3, 3 threes are 9, 3, 3 ones are 3, and we get the right answer. So the takeaway over here is that we need to insert a 0 when it is required, because we always put 1 digit down, not more than it. Expanding the algebraic expressions. Now this is another point, another source of concern. Most of the students will expand this as, what is a plus 5 the whole square? And they will write, it is a square plus 5 square. And that is a square plus 25. Which is wrong. Because whenever we have a plus b the whole square, or a minus b the whole square, we have a square. Then we write the plus or the minus. The 2 multiplied by a multiplied by b. And then we write a plus, always a plus over here. And then a b square. So the correct answer to a plus 5 the whole square would be a squared plus 2 multiplied by a multiplied by 5 plus 5 squared. And then 2 multiplied by a multiplied by 5 will be simplified as 10a, a squared, and 5 squared 25 are all 3 different terms. And now we have the correct answer. Similarly, what is square root of a plus or minus b? For example, try to find what is the mistake in this particular thing. Square root of 9 plus 25. So square root of 9 is 3, plus as it is, square root of 25 is 5, 3 plus 5 is 8, but that's wrong. Why is this wrong? We are going to understand this in a moment. But remember the rule. Square root of a plus or minus b is simply not equal to square root of a plus or minus square root of b. But square root of a multiplied by b is equal to square root of a multiplied by square root of b. So if there is a multiplication sign, you can split it. You can split the radical, but not the plus or the minus sign. You can also split in case of there is a division. Similarly, 1 upon a plus or minus b is not equal to 1 upon a plus or minus 1 upon b. Simply not equal to. But if there is a multiplication sign, we can definitely write this as 1 upon a multiplied by 1 upon b. Now the question is, why is this wrong? Why is this first rule true? Why is it not equal to? The reason is because 9 plus 25 is 34, and square root of 34 is not definitely equal to 8, because square root of 64 is equal to 8. So how do we solve this? We simply cannot solve this, and square root of 34 is the right answer. But what if we had a multiplication sign in between? Then of course we can go by this rule, and we can simply write this as square root of 9 is 3 multiplied as it is square root of 25 is 5, and we have 15. And 25 nines is 225, and the square root of 225 is 15, so that's true. So remember this rule. Now we come to the next part where a lot of students make mistakes. It's like terms. I've seen many students do this, which is wrong. Remember, I'm warning you. 5x plus 6 is equal to 41. So what do? They add the 5 and 6, they write 11x. The x has been borrowed from here. Is equal to 41. Now 11 and x are multiplying. It goes over the other side, becomes divided by 11. 41 upon 11. That's wrong. Why is it wrong? Because 5x and 6 are not like terms. However, 6 and 41 both are constants. X is a variable. 6 and 41 are constants. So 6 over here is being added to 5x. We can subtract 6 on both sides. And we say that 6 goes on the other side, becomes minus 6. And 41 minus 6 is 35. 5 being multiplying over here, can divide over there. 35 upon 5 is 7. This is correct. So what did we learn? That 5x plus 6 simply do not add up to 11x. Let's do another one. 4y minus 2 is equal to 3y plus 1. So remember, y's are like terms, and minus 2 and plus 1 are constants, and they are also like terms. So the minus 2 can go on the other side, while the variable y can come on this side. So we have plus 3y coming on this side, becoming minus 3y, minus 2 going on the other side, becoming plus 2. And we have 1y is equal to 3, or simply y is equal to 3. Addition versus multiplication. Another mistake that students commit is this. What is a plus a? And they write a cubed is equal to 27, and then cube rooting both sides, they get 3. But remember this rule, that x plus x is 2x and not x squared. So when is it x squared? When x and x are multiplied, it becomes a x squared. This is a very, very simple thing, and a lot of students do get confused. So what is the right method to solve this previous sum? So a plus a is simply 3a. 3a is 27, and a is equal to 27 upon 3, which is 9. And how do we solve this? 4y multiplied by 3y multiplied by 5y is equal to 20,580. So we can take the 4's and the 3's and the y's, the 5's on the other side, and y multiplied by y multiplied by y will become y cubed. And 2580 will be divided by 4, 3, and 5. And on simplifying this, on solving this, you get 343. Now taking cube root on both sides, we get 7. The order of operations. You have learned in your schools about BODMAS. I've a little bit modified that to BADMAS. I'll be showing you in a moment. So, first of all, we are going to see what is the wrong way of doing this. 5 plus 4 multiplied by 2. And students add the 5 and 4, making it 9 multiplied by 2 is 18. That's wrong, because we are going to follow the rule called BADMAS, which is a slight modification of BODMAS. So B stands for bracket open, E stands for exponent or exponential power, D stands for division, M for multiplication, A for addition, S for subtraction. Division and multiplication can be done together, or multiplication can precede division or division can precede multiplication. Similarly, the same thing for addition and subtraction. You can do addition first or subtraction first, no problem. But you need to do the division multiplication first, then the addition subtraction. And if division and multiplication are there together, if they have the same precedence, always go from left to right. So what does that mean? I'm going to show you in a moment. So let's return back to this previous question. 5 plus 4 multiplied by 2. There is no bracket over here. There is no exponential sign. So comes multiplication division. So we have to multiply first and then do the addition part. So 4 twos is 8, and then 5 plus 8 is 13. So that is the correct answer. What about this? Suppose if a student does this. 6 plus 7 is 13. So 9 plus 5 minus 6 plus 7. 9 plus 5 minus 13. 9 plus 5 is 14, minus as it is 13 as it is, and he or she gets a 1. Why is this wrong? Okay, let's try to understand that. So let us do 9 plus 5 first, which is 14, and then 14 minus 6, which is 8. 8 plus 7, 15. So why are we getting different answers? So certainly one of them is wrong. Of course, this is wrong and this is right. But what is wrong in this? Or where did we go wrong? The answer to this is, we did not take this minus sign while taking 6 plus 7. It is actually minus 6 plus 7. This minus sign belongs to 6. So 6 plus 7 is definitely 13. But the problem is, this is not 6, but minus 6. So minus 6 plus 7 is 1. And 9 plus 5 plus 1 is 15. And then you get the correct answer. Let's do more examples. What is 6 divided by 2, bracket open, 1 plus 2? So first of all, we need to open the bracket, or we need to solve everything which is inside the bracket. So what is 1 plus 2? It is 3. And then we can just simply write this as 2 multiplied by 3. And then 2 threes are 6. 6 divided by 6 is 1. Oh, is that wrong? What is wrong in this now? Because we have been told that if there is the same precedence, we should always go from left to right. So you saw there was a same precedence over here. Division and multiplication have the same precedence. So we should have done this first from left to right. But what did we do? We did this first. 2 multiplied by 3 is 6. So the correct way of solving this is, first open the bracket. 1 plus 2 is 3. 2 into 3 can be written like 2 into 3. First divide 6 and 2. Go from left to right if you have the same precedence. So 6 divided by 2 is 3, and 3 threes is 9. Now this is correct. What about this? 3 multiplied by 4 squared multiplied by 5. So 3 fours is 12. 12 square multiplied by 5. 12 square is 144. 144 multiplied by 5 is 720. Now this is wrong because 4 squared is an exponent. So first we should do or deal with the exponent and then multiply the numbers. So the correct way of doing this is 4 square is 16 and then multiply by numbers, and you'll be getting the correct answer. A divided by B divided by C. So what is A divided by B divided by C? It depends whether it is A divided by B first, then divided by C, or A divided by B divided by C first. Which means the first thing can be written like this: A divided by B the whole upon C, which is A divided by B divided by C, which is A divided by B, and then we make this division multiplication. So assuming there is a 1 in the denominator, 1 goes above, C comes down. A multiplied by 1 is A, B multiplied by C is BC. So it is A the whole upon b into c. And if it is the second part, it is a divided by b upon c, which is a divided by b upon c, which is a multiplied by c upon b, taking reciprocals, and a multiplied by c is ac upon b, and these two are definitely not the same things. So, which is more preferable? The first part is more preferable because if there is the same precedence, always go from left to right. Take the division on the left side first, going towards the right side. So the correct answer to this would be the first line divided by the product of the second and the third line. Changing the signs in inequalities. Minus 3x is greater or equal to 9. If we divide minus 3 on both sides, we get this. On further simplification, we get x is greater or equal to minus 3. But this is wrong. The reason is, when we deal with inequalities like this, you don't change the sign while adding or subtracting any number. You don't change the sign while multiplying or dividing positive numbers. So if the numbers are positive, if you're multiplying them or dividing them, don't change the sign. Adding, subtracting, never change the signs. Only change the sign while multiplying or dividing negative numbers. In this case, we have divided minus 3 on both sides. So we have divided a negative number. So we need to change the sign. Alternately, if you don't want to change the sign, you can change the sides. So we are going to understand this in a moment. So let's take the previous example. So the minute we divide minus 3 on both sides, this greater or equal to sign becomes lesser or equal to sign. So 9 divided by minus 3 is minus 3. So this is the correct answer. X is lesser or equal to minus 3. Let's take another one. Minus 6 is lesser or equal to minus 3x is lesser than 9. Dividing throughout by minus 3. Now we have two options. Either we can change the signs or we can change the sides. I've changed the sides over here. So I've taken the 9 first on the extreme left, minus 6 on the extreme right, and I've not changed the sign. I've taken this lesser than sign as it is and the greater less or equal to sign as it is. And I've divided minus 3 on all the sides. And the answer to this becomes minus 3 is less than x is less or equal to 2. And finally, we are going to see how to deal with rational expressions. A very common mistake is this: 12x plus 16xy the whole upon 4x. What do the students do? They simply cut the 4s and the 12s, 4 1s or 4 3s, and the x's cancel. But this is totally rubbish. This is wrong. Cancellation is only allowed if the numbers are factors or multiples with the brackets or the rest of the numerator or denominator. That means if you see a plus or minus sign outside the brackets, then you cannot cancel. So you can see there is a plus sign outside the bracket. Simply you cannot cancel these things. So what is the correct way of dealing with this? We can factorize the numerator. We know 12 and 16 both go in the table of 4, and there is a x also common. So we can take 4x common, and 3 plus 4y will remain in the bracket. And then we can cancel the 4s and the x's, because the 4s can get cancelled because it is 4 multiplied by x multiplied by the entire bracket, and we have a 4 multiplied by x. So 4 and 4 can cancel, x get cancels, and we have 3 plus 4y the whole upon 1, which is 3 plus 4y. We can ignore the 1 in the denominator. So remember, cancellation is only allowed if there are numbers of which are factors or multiples with brackets. So where your 4 and x were multiples of each other, they were multiplying with each other, and they were also being multiplied with the bracket, or the rest of the numerator or denominator. That means if you see a plus or minus sign outside the bracket, we do not see any plus or minus sign outside the bracket. But if we see, we cannot simply cancel. But we could cancel over here because the plus sign was inside the bracket and we did not cancel anything inside. So we did not cancel this 4 with this 4. How about this? X plus 3 the whole upon x plus 5. There are no brackets, but there is a plus sign outside the bracket. So x is not multiplying with 3, neither is x multiplying with 5. So this x and this x will not cancel. Of course, don't cancel the pluses. And this is already simplified. You don't cancel anything. So what about this? In quadrant equations, when you simplify the formula by formula method, you may end up somewhere over here. 4 plus or minus square root of 20 the whole upon 2. Can we cancel this 2 1s and 2 2s? Definitely not. We can actually factorize the 20 to get 2 multiplied by 2 multiplied by 5, and then we can take a 2 outside the square root sign. Out of every 2 2's, 1 2 can come out. Then can we cancel this 2? No, because there is a plus or minus sign outside the bracket. We simply cannot cancel. Remember this rule. But we can take a 2 common or factorized in the numerator. So 2 2's is 4, and the 2 gets removed outside the bracket. And now we can finally cancel this 2 and this 2 to get the final answer is 2 plus or minus root 5. And what about this? 6x squared plus x minus 15 the whole upon 2x squared minus 17x plus 21. Can we cancel the x squares? No, because there is a plus or minus sign outside the bracket. Can we cancel 2 and 6? No, because 2 is being multiplied with x squared, but the x squared or 2x squared itself is being added or subtracted to the rest of the part. But we can of course factorize this. We can find a number or two numbers such that on subtraction you get 1 and on multiplication you get 15 6 which is 90. So we get two numbers plus 10x and minus 9x, and in the same way in the denominator you can factorize this to get these two factors, and now you can cancel the 2x minus 3's and the remainder is the answer. I hope you understood this. So do like and share if you like this, and keep in touch, keep watching. Thank you.